Okay, today's topic is deterministic finite automata. A deterministic finite automata is a logical machine that I can use for accepting a regular language. Regular language will have simple rules, something like all the strings in this language will start with a, contains ABB, ends with ABA. So these are the rules with which I can form regular languages, and deterministic finite automata is a logical machine. I can formally define a DFA in a quintuple, that is, it has 5 elements in its tuple. I can use any letter over here, D, M, A, F, as per your wish. I have used D. Now there are 5 elements over here. Q is the set of states. Sigma is the set of input symbols. Delta is the set of transitions. This can be represented in a table, or it can be represented as a transition diagram, or you can write down each of the rules separately. So there are many ways of representing the set of transitions. The common representation that we will follow is Q cross a symbol will be giving Q. That is, a state on receiving a certain symbol will go to another state. Q naught is the start state. There will always be only one start state in a finite machine. And F is the set of final states. There can be one or more. There has to be at least one. There is no condition that there has to be. If we are accepting empty strings, then or nulls language, we'll come to that later. Okay. So a set of final states. Now we'll take one simple example over here, how to construct a or how to design a DFA for accepting this language, which is containing strings that end with ABB over the input in symbols A and B. Okay. So first step that I will do is I'll write down the basic strings. Now what is the basic string that this automata has to accept? Since the condition says ends with ABB, I can start with anything, and that anything can be null as well. So let's say I don't start, I have an empty string, and then I get ABB as the 3 letters, and then I have nothing. So that means ABB is the basic string or the minimum string that has to be accepted by this DFA. So my basic string for this language is ABB. Now other accepted strings, you can start with anything because the condition says ends with. So I can start with anything. I can start with another A. I can start with a B. I can start with any combination. Right? There are many, it's an infinite set. What will be the set of rejected strings? That is what should not be accepted by this DFA. Since the condition says ends with ABB, if I end the string with anything other than ABB, now the last 3 characters are BBA, that means it is an invalid string, or this string should not be accepted by the DFA that I'm going to design. Or again, this is also an infinite set. Basically, any combination which does not have the last 3 characters as ABB should not be accepted by this DFA. Okay, since I have already listed the basic strings accepted, rejected, now I'll go into the pictorial representation of this language. So since my basic string is ABB, let me first try to accept ABB. So I'll put one start state. I'll put another state for accepting A. I'll put a state for accepting B. And I'll put one final state over here. Since I have accepted the basic string ABB, I'll reach the final state over here. Now this particular diagram is not complete. The reason is for a DFA will need transitions on every input symbol on every state, right? Every state should be able to handle all the input symbols. You cannot leave anything uh, as ambiguous or it should undefined. So if you look at the Q naught state, it knows what should be done on getting a, but it doesn't know what should be done on getting a B, right? So my condition says ends with ABB, so it doesn't matter what I start with, right? I can start with a B, I can start with any number of B's, so I can put a self loop over here for accepting B. Now Q naught is done. There are two input symbols A and B. I know what to do on getting a A, I know what to do on getting a B. Next I move to Q1 state. Q1 knows what to do on getting a B. It doesn't know what to do on getting a A. Again, look at the condition. It says ends with ABB. So it doesn't matter how many A's are prior to this. I can have A, and then BB at the end. So the last three symbols will again remain as ABB, right? A, Still the condition of ends with ABB is satisfied. Now, Q1 is done, A and B. Now Q2 state. Q2 state, if I know what to do on getting a B, what do I do on getting a A? If I give a self loop, what will be the string that I accept over here? A, B, B. Will that be a valid string for this machine? No, it's not. So I cannot give a self loop over here for A. Instead, I'll have to make sure I get the combination ABB once again. So if I give this loop, or if I put a transition back to the Q1 state, if I land up over here, A, B, and then I have to get another A and then BB to reach the final state. Only when I reach the final state, I can say that the string is valid. So B, B, correct? So then I can say that this is a valid string. Okay. Now again, in Q2 state, I have handled A and B. Q3 state, I have neither handled A or B. What do I do on getting a or B? Can I give a self loop? If I give a self loop, the meaning is once I accept ABB, I can accept anything after that, any combination, ABB, B, anything. That's not what the question says. It says ends with ABB clearly. So I cannot give a self loop over here. If I bring it back to this state, I cannot accept, I will still not get the combination of A and B. Now let's say if I get A in Q3 state. So if I get a, I need a BB as well to follow. So let's say I have to come back over here. If I get a on Q3 state, I will need a BB. Only then I have the pattern ABB to reach the final state, right? Now if I get a B in Q3 state, I cannot come here. I cannot give a self loop. I cannot come here. If I come here, you will be accepting BB. If I come here, you will be accepting BB. If I come here, then to reach the final state, I will again need A, B, B. Correct? This is the only option I have. Okay. So now I can say my DFA is complete because on every state, I have handled every single input symbol. Okay. Now I have shown the pictorial representation, also called as my state diagram. Okay, once my state diagram is over, you can make the state table. Now making the state table is very simple. You just look at the diagram and fill the table. State table, transition table, you can call it whatever you want. How to fill the table. Now first thing, how many states are there? I have 4 states. So that means my table is going to have 4 entries. So I need a set of states, I need the set of input symbols. I have 2 input symbols A and B. I have 4 states Q0, Q1, Q2, Q3. I have 4 states. What is the start state over here? Q0 is the start state. You will be representing the start state with the arrow. What is the final state? In this case, I have only one final state, which is Q3. Q3 you will be representing with a star on the top. Okay. Once I have filled all the basic details, let me start filling the table. Q0 on receiving a, what it does? Q0 on receiving a, what it does? It goes to Q1. Q0 on getting a B remains in Q0. Q1 on getting a remains in Q1. Q1 on getting a B goes to Q2. Q2 on getting a A comes to Q1. Q2 on getting a B goes to Q3. Q3 on getting a A goes to Q1. Q3 on getting a B goes to Q2, Q0. Okay, so just look at the state diagram and fill the state table or the transition table. This is my delta, right? The delta that is given in the formal definition, delta, which is the set of transitions, is given over here. Q is the set of states, sigma is the set of input symbols, delta is the set of transitions, Q0 is the start state, and Q3 is the final state. Okay, so this is the definition or the design of the diagram. Now you will have to show a verification whether the uh, given question meets the requirement or not. Now how to show the verification? First you can show a accepted string. So let's take one example of a accepted string. You can check any of these examples. Now I'll just take A, B, B as my accepted string example. Okay, so always we are going to start with Q naught and the first symbol over here A. Okay, delta is the transition from Q naught on getting a A. What does it do? Q naught on getting a A, it goes to Q1. Okay, next delta Q1 on getting the next input symbol, that is A. Again Q1 on getting a A, what does it do? Q1 on getting a A remains in Q1. Again next Q1 on getting the next input symbol, which is B now. Q1 on getting a B goes to Q2. Next Q2 on getting a B. Q2 on getting a B goes to Q3. Now your string is over. The example string that you have taken is AABB is over. So at the end of the string, you have an end of string character that is represented by dollar here. So your Q3 state is going to read dollar, which is the end of string character. And what does it do? Now, if Q3 is a final state and you read the end of string character, then you can say accept. If Q3 had been a non-final state and you read the end of string character, then you will say it is reject. Now we'll take one more example of a rejected string. Let's take an example, let's say A, B, B, A, this example, okay? So I'm just going to take again the same concept, Q naught, you'll always start with Q naught, which is my start state, and the first input symbol, okay? So Q naught on reading a A goes to Q1. Q1 on reading the next input symbol. The next input symbol is B. Q1 on reading a B goes to Q2. Q2 on reading the next B. This is the next input symbol. Q2 on reading a B goes to Q3. Q3 on reading the next input symbol, which is A over here. Q3 on reading a A goes to Q1. Q1 on reading a, we have the end of string character now. So Q1 on reading the end of string character. Q1 is not a final state. It is a non-final state. So if I'm reading the end of string character in a non-final state, I will reject it. It is not valid. Okay. So this is my example of how to construct a DFA. What is a DFA and how to construct a DFA. We'll take some more examples in the next video.